Example 7. Suppose that your company is considering a project that will produce a cash flow of $4,000 for the next 5 years. Starting in year 6, the project is expected to generate a cash flow of $6,000 per year forever. What is the present value of all future cash flows if the interest rate is 8%? So this one's a little bit tricky. As you can see, we're going to be dealing with two types of cash flow patterns. Okay, so we'll calculate the present value separately and we'll just add them up. Okay. So, as always, we're going to start by drawing the timeline. So this problem, this timeline looks like this. So for the first 5 years, the project will generate $4,000. And starting in year 6, we have a perpetuity of $6,000. So this will go on forever. Okay. So the goal is to find the present value of everything if the R is 8%. The interest rate is 8%. I'm trying to calculate the present value of everything. Okay. So the first thing we do in multiple cash flow problems is we first recognize what type of cash flow pattern that we're working with. Here we have two different patterns. Okay, so the first one I'll highlight in light blue. So this one is an annuity. Okay, and the second one we have a perpetuity. Okay, so it goes on forever. Okay, so I'll just write it down. The first one is an annuity. Second one is a perpetuity. Okay, so if I were to write everything out a little bit more formally, the present value of everything is, I'll just call it NPV, okay, net present value. NPV of everything is equal to the present value of the annuity component. Just write annuity component plus the present value of the perpetuity component. Present value of the perpetuity. Okay. Okay. So yeah, we'll work through each component separately. Let's first do the annuity part because that's easier. So present value of the annuity, we'll use the present value of an annuity formula, right? It's the PVA formula. PVA as of time 0 is cash flow that occurs in year 1 over R, 1 minus 1 over 1 plus R to the nth power. Okay, so again, the PVA formula looks like this: cash flow T plus 1 over R, and then we have the component there. Here we always check when the first cash flow occurs in the annuity. Here it occurs in year 1. Okay, so when you use the formula, you'll get the value as of year 0 immediately. Okay, so just okay, so we plug the numbers in. Cash flow is 4,000. R is 8%. We have 1 minus 1 over 1.08, 1 plus R to the fifth power. Okay? N is 5 because we have an annuity whose contract was signed in time 0, and it's a 5-year annuity. Okay? Okay. So the present value of an annuity is 15970.84. Okay. So note that this is already in time 0. Okay, we have PVA as of time 0, right? So this is in time $0. So we'll keep this number. Okay. So the second part is getting the present value of this perpetuity. Okay, so we'll take care of the second part. Okay. So that one is a little bit more complicated. So yeah, so some of you might already notice that since the first cash flow of the perpetuity occurs in year 6, if you use the present value of a perpetuity formula, you get the value as of year 5. Okay? Just like how the annuity formula works. So we'll first get the PVP, present value of the perpetuity, as of year 5, and then we'll discount it back to time 0. Use this to get the time 0 value of the perpetuity. Okay, so we're doing the PVP formula first. Again, we still have the T and T plus 1 relationship. So again, the first cash flow occurs in year 6. Okay, so T plus 1 is 6, which means T is 5. So the value that you get when you use the formula is in year 5. So PVP 5 is equal to the $6,000 over R, 0.08. This value is $75,000, but again, this is in time $5. Okay, but we want the value as of year 0, so we have to take a second step. We'll use the PV formula, which is future value divided by 1 plus R to the nth power. Okay. So we're going to use the PVP5 as the future value. So PV0 is this PVP5 divided by 1 plus R to the nth power, and is 5. Okay. So $75,000 over 1.08 to the 5th power, since this value is in year $5. Okay. So this will give us 51043.74. Now this value is in time $0, which is what we want. So we're going to add this 15,970.84 and this number to get the NPV. Okay, so again, this was this number, this was this number. Okay, so the NPV, the net present value of all of the cash flows, is just 15,970.84 plus 51,043.74, and that's $67,014.58. Yeah, so this one's a little bit complicated, but we're just calculating the net present value of two types of cash flows. One's an annuity and one was a perpetuity.